Alrighty, thank you all for coming to this session. So again, my name is Kevin, and I am a software engineer at RStudio, and I spend most of my time building open source packages for data analytics and machine learning. And today we're going to talk about how to deploy Spark ML models from R. So this is a brief agenda. So we'll first talk a little bit about the deployment problem to give some context and background. To motivate some of the effort that the community has been putting into facilitate model deployment. We'll give a quick overview or a review for most of you, I think, of ML pipelines, because they're the structure that underlies some of these deployment mechanisms. And then we'll conclude by going through a couple of ways to deploy these models and a quick demo. So what do we mean by deployment or putting machine learning models into production? It may mean different things to different people, but for the purpose of this session, we're just going to say is to make it so that someone else can consume your model after it's been built. So it can be another user, or it could be an application. So one way to look at the different modes of deployment is to look at how quickly you need the predictions to be returned. So on the one end of the spectrum, you have batch processing. So this could be, you need to score tens of millions of rows, and this could be event-based or time-based. A use case could be something like if you're a bank, and then every night you want to do some risk scores on your entire portfolio. So it's, in this case, it's okay to take a while, a few minutes, few hours even. On the other end of the spectrum, we have a real-time on-demand predictions. So now we're talking a few seconds in terms of like human real-time or under a second. And these would be things like instant decisions on credit card applications, or trying to detect fraudulent transactions as they occur. So if you've tried to do machine learning deployment in an organization, you probably run into a few different pain points. And we're going to just rant a little bit about why this problem can be hard. So first of all, putting these models in production involves different expertise, data science, software engineering, and some project management to put everything together. And as you involve more people, you run into more issues. This is a cute little graphic I saw on a talk from a couple of years back. But basically, people in different roles, data engineers, data scientists, and project managers, sometimes they care about different things, right? And so friction between teams is one source of hardship, I guess. And then another challenge is that there are just so many different ways you can deploy models today. So if you do a search or just look at some of the talks from recent conferences, just for Spark ML, there's a ton of different ways you can quote unquote deploy models. So there's the native Spark ML persistence API. There's PMML, which was promising but doesn't work very well. There's PFA and Alvark, which I don't think is open source yet. And there's a few other different things. So along with that, there are a lot of different machine learning frameworks. So even though today we're focused on Spark, I think it's important to keep in mind that all of these different choices sort of, is a resource trend on the people that are trying to put these models into production. So this is one potential conversation that may occur. This is the quintessential handoff problem. So the data scientist might have spent some time building and tuning a model, and it's ready for deployment. And the engineer will come back and say, okay, our Python is not really performant. We have to do it in our performance framework. So then we need to recode your tree models. So then, these types of conversations still happen at some organizations, but maybe not if you are at a tech company that has really gotten it down with some custom workflows. But just a quick poll, can anyone relate to this? Oh, a little bit? Yeah, okay. So since this is a talk on doing this from R, we also want to point out a couple of demographic comments. So R users tend to be have more math stats backgrounds, and then they tend to have a little less like formal CS and software engineering training. So then it's slightly tougher for them to collaborate or share the same language as the folks that are doing the implementation. So this is a generalization, but I think on average, this is one thing that I've seen from the places I've worked at. A couple trends today, we see that data scientists are more comfortable working with different technologies, moving up and down the stack. And there's also been quite a bit of active development in the different technologies to sort of facilitate this handoff. So with all that in mind, technology won't solve all your cultural issues, but it can make collaboration easier. And I think this is a theme that we've seen from the keynote and some of the other talks. So next up, we're going to get a little more technical and talk about some of the mechanisms to actually deploy these models. So who has used Spark ML pipelines before? Okay, good. I think that's about half the room. So we'll just do a quick overview. So pipelines is a feature that's been in Spark for a while, but basically it's a structure in which you can throw in your data transformers and machine learning models. So if you think about it, when you deploy a model, you not only have to deploy the machine learning piece of it, you also have to worry about some of the data pre-processing that happens. So as an example, maybe in your model, you have as a predictor a categorical variable that represents like age buckets. But then during deployment, maybe these things come in as continuous values. So then that there's an extra step that you need to do to your data. So a pipeline basically encapsulates your feature engineering steps and your classifier or regressor. So the building blocks of pipelines are transformers and estimators. And a transformer basically takes a data frame and then return the data frame. So an example would be like a tokenizer that would take in some raw text data and then spit out a vector column of word tokens. And an estimator, on the other hand, will take a data frame and then learn a transformer from it. So an example could be like a logistic regression algorithm. And then you can feed it some data, and then it's going to learn a logistic regression model, which is a transformer, and then you can take that to score a data frame and then output a data frame with some predictions. So let's move on to this slide. So here we have an example of a pipeline. And in this case, we have a couple of transformers and an estimator. So you can think of the transformers as feature engineering steps, and then the estimator could be like a classifier. So using the MLfit function, when you pass in a pipeline and a data frame, you end up with a pipeline model, with the two transformers from before. But then now your classifier has been trained, so now you can use it to make some predictions. So this pipeline model, again, just encapsulates all the feature engineering that needs to be done to the data set that's coming in and also the prediction piece of it. So then the trick here is to persist this pipeline model so we can use it to serve predictions later on. And the two ways that we're going to demo today, one is we're going to use the native Spark ML support for model persistence. And then we're going to talk about the MLeap package, which provides an interface to the open source MLeap library. So let's move on to the demo, and then we'll talk more about these technologies as we go along. So here's Okay, I think this is okay. Can we, is this okay? Should I make it a little bigger? All right, here we go. So I'm gonna start running some code and then we'll talk about what it's doing. Okay. So if you have used sparklyr before, some of this should be somewhat familiar. So here we're loading a few R packages, and then we're making a Spark connection in local mode. And then what we're going to do for this toy example, we're going to copy over some flights data. So this is a way to sort of copy a local R data frame into our Spark station. And then this is some standard dplyr to do some basic data transformation. So in this data set, each row corresponds to a flight that departed from the New York City area in 2013. And then it has a bunch of characteristics for the flight. So things like where it's departing from, where it's going, and then what we're interested in is how much it was delayed upon arrival, and then we also have information on what was the delays upon departure. So here, our goal is to build a model that's going to predict the arrival delay variable, given that we know where it's going and then what was the delay upon departure. So here is a way we can define the pipeline. So in sparklyr, you can define an empty pipeline by using the MLpipeline function, and then you can use the pipe operator to add additional pipeline stages. So in this case, we're adding a feature hasher that's going to take the origin and destination airports and then create a new column called airports. And then we're going to combine that with the departure delay variable. So this the vector assembler is just a standard way in SparkML to sort of create your features column. And then after the data prep step, what we're going to do is we're going to put a regressor at the end of it, and then we're going to try to predict arrival delay. So you can print this object, and it's going to tell you, okay, you get a pipeline with these stages. So we have a feature hasher, a vector assembler, and a random forest regressor. And notice that this is an estimator, so it has to be fit to some data before we can use it for prediction. And then what we're going to do is we're going to do a little bit of hyperparameter tuning on the random forest. So then we're going to tune the subsampling rate and the max depth. And then we are going to run a cross-validation exercise on this using threefold cross-validation. So this is still running. We'll let it finish. But when you are using sparklyr as an aside, you can always look at the Spark UI to see what is going on in the backend. So again, sparklyr, for those of you who are not familiar, is really just an interface to Spark. So you can see what's going on there, and then let's see if it has finished running, thank God. Okay, so now we have our cross-validated model, and then we can see that we have some performance metrics associated with each of the hyperparameter combinations. And of course, in real life, you will work with a lot more variables, and your grid might be quite a bit bigger. But in this case, we see that, okay, we don't want to subsample our data set for each tree, and then we're going to use that particular depth hyperparameter. So then we can take that same data prep step, pipeline, sub-pipeline in a sense, and then put the new random forest regressor with the appropriate hyperparameters in there. And then now we're going to fit this model on all of the data instead of what we did before was training on 2/3 of the data for 3 times. So once that's complete, we're going to we're going to save the models, persist the models onto disk. And then here, the ML save function is actually invoking the model writer that comes with Spark ML. So this will save a Spark ML pipeline. And then ML write bundle is a function from the MLeap package. So it's also going to serialize your model to disk, but it's doing it a little differently. So in the Spark case, it's doing a combination of JSON and Parquet, and whereas for MLeap, it's just right into JSON. So next, we're going to actually test that these model artifacts actually work. And then we have to put a disclaimer here saying that we're doing everything from R with a lot of overhead. So this workflow really is for testing purposes. So the data scientist doesn't have to leave the ecosystem to see that their model artifacts can be deployed. So in real life, I guess you would hand over these artifacts to the implementation engineers, and then they'll be able to deploy them or embed them in the applications. So let's first look at deploying the ML pipeline that's saved using the native Spark API. And then what we're doing here is we're initiating a local Spark session. We're loading the pipeline files into a Spark model object. We're going to take in the predictors from an outside source, and then we're going to put those predictors into a data frame, copy this data frame into the Spark session, and then we're going to invoke the transform method on this pipeline model to get a prediction. So let's see. So we see that this one is on port 8132. And if we copy this over, hopefully we can. All right, so let's see. Okay, so now we're going to pretend that we're trying to see if a flight, how much a flight is going to be delayed if it's going from O'Hare to San Francisco, and then on departure, it was delayed for 10 minutes. Okay, so the zoom is a little funny. So we see that we get some results back here. So it's saying that, oh, okay, you actually arrived early. Let's do that a couple more times just to see if we get the same number. Okay, we do get the same number. Okay, so then the takeaway here is that if you do all of this overhead and then do the prediction on the cluster, so even if you're just working with one row of data, there's quite a bit of overhead that goes on. So then here we're looking at something like around 400 milliseconds. And if we stop this thing, there we go. And then try to deploy the MLeap bundle that we also serialized. So what this is doing then is almost the same exact interface from the user point of view. So we're going to load this bundle into an MLeap model object. And then again, we're going to take in some predictors. We're going to save it into an R data frame. And then we're going to invoke the transform method. So what's happening here in the backend is that MLeap, the MLeap runtime is just a Java dependency. So we're using RJava to sort of serialize the R data to Java and then doing the prediction there. and getting the prediction back. And so this is hosted in the exact same place. So then theoretically, we should be able to just post the same request to the endpoint. And we see that, okay, we still have the same result, which is promising. And then we see that the latency has gone down to about, let's do that a few more times. So around like 30, 40 milliseconds. So then, so that's an order of magnitude improvement, even though we're just doing everything from R. So in practice, you have to take into account a bunch of different things. Here, everything is local. So depending on your application, you might get better or worse results. But the idea here is that, going back to our slides, depending on your use case, if you need to score tens of millions of rows, then it might be better to just run it in a Spark job. But if you want to do real-time or really low latency predictions, if you have requirements for that, then something like MLeap would be better. And the cool thing about MLeap here is that it doesn't require a Spark session, and then you can run on any device that supports the JVM. And then one of the, I guess there were a few reasons why we chose to move with MLeap instead of some other packages. We feel like it has pretty good coverage on the different Spark ML transformers that are available today, and then it's open source, and it seems to be somewhat widely used, even though it's the technology stack for deploying these models is pretty fragmented right now. But we'll always be watching the different developments to see what we can do better for the R data scientists. So then, to wrap up, here's the deployment story that we're trying to go for. So, the data scientists will build the models, do all the tuning that they need, and then hand over some artifacts to the engineers and then with some documentation, and then the engineers will be will be able to easier embed these into their applications. And then when you need to update your model, you don't need to go back and recode, all of your GBM or random forest. You basically just need to change the model artifact that the data scientists produced. And then the engineers now can, work on what they care about, like, containerize things and orchestrate in Kubernetes, and then go to conferences and talk about them. Anyway, so yeah, so that's a wrap, and we might actually have a few minutes for questions. Yes, you.
Can you come to one of the mics and use, please?
Oh, okay, let's do that.
Have you used MLeap with Shiny at all? And how would you integrate it with a Shiny app?
That's a good question. So if you talk to our solutions engineers, they always recommend that you don't use sparklyr with Shiny, because Spark wasn't really designed for a bunch of different users all hitting it at the same time. But if you're doing something right now and it seems to work, just stick with it. But you can also consider using the MLeap package if you do have a bunch of users, and then you really need to do real-time scoring. One way you can expose some of this data to Shiny apps is to do like the predictions ahead of time and store it in the database, and then the Shiny app will talk to that database. But then if you you have so many different combinations that's not feasible, then definitely consider some of the technologies that we described today.
What versions of Spark does this support? Can I use this library to run on a previous version of Spark?
Previous version of Spark? So I believe that the upstream library MLeap I think it supports 2.0 and above. But like, for example, the feature hasher transformer was introduced in Spark 2.3. So if you wanted to use that, then of course you need to have Spark 2.3. But then one of the the philosophies of sparklyr is that it can support different versions of Spark, whereas sparklyr will be tied to specific Spark releases. So then we try to make it backwards compatible. If you give it a shot and something doesn't work, let us know.
The example that you presented today, they are running on an application, right? You're just a plumber to actually make it a REST application. What about if I got the whole model and just want to put it into the Spark cluster or Spark streaming to actually do the scoring, not just plumber as a REST service? Can I do that from Spark? Can I just put that directly as an application for Spark streaming, for example?
So I'm not that familiar with the interaction with Spark streaming, but I do know that the ML pipelines that you save from sparklyr, they are like fully interoperable with the Scala and Python APIs. So then if you save like a pipeline model from sparklyr, you can in Scala you can load that in and then do basically whatever you want with it. We good? All right. Thank you all again.
Thank you.